Hello, and thank you for joining us. In this video, we'll be discussing drawing the graph of an exponential function from transformations. So let's say we have f of x equals 2 to the x and g of x is equal to negative 2 raised to the x plus 1 minus 3. Right, so it's really 2 raised to the x plus 1 times the negative and then subtracting 3. So if we want to state the transformations to go from f of x to g of x, one of the things that we can think about is that g of x could be written as negative f of x plus 1 minus 3. So if I was going to then identify the transformations that I have for part A, right, I could say that with the negative out in front of the function, I have a reflection, well, let's spell that correctly, reflection in the x-axis, right, followed by a movement left of 1 unit, and that could be set in the negative x direction. And then lastly, we have a movement down of 3 units. And we could say that that's in the negative y direction. So we could say, hey, 1 unit in the negative x direction, 3 units in the negative y direction. And that reflection in the x-axis. That reflection in the x-axis does need to occur before the discussion of moving down 3 units. Okay. If we want to write the domain and the range, if we want to write the domain and the range of g, it's helpful to know what the graph of f basically looks like, which is an exponential function, right? And we have exponential growth where that base is greater than 1. So I have a basic function that looks like that. If I reflect in the x-axis, that's changing my range, because right over here, my range is normally y greater than 0. Well, reflecting it in the x-axis is going to make the range y less than 0. If I move to the left by 1 unit, that affects my domain, but my domain is all real numbers, so moving to the left by 1 unit doesn't change my domain. And then lastly, I move down by 3 units, so that reflection on the x-axis then needs to go down further 3 units. So I could identify the domain and the range for this particular function and be able to say, hey, the domain is all real numbers, right? And the range for this particular function is that y is going to be less than negative 3. Okay, so let's go ahead and sketch this graph and identify intersections with the coordinate axes, as well as equations of asymptotes and the coordinates of at least 3 points on the graph of G. So we'll come in and let's just draw a set of axes. So here is a set of axes, and I can come over and I can say that's my y-axis. Here's my x-axis. Okay, so if I know that I've got these transformations and I know y is going to be less than negative 3, then I can come over here and draw my horizontal asymptote, y equals negative 3. And I know that I'm reflecting over the x-axis, moving to the left by 1 unit and moving down. So my graph might look a little something like that. The only intersection I have with the coordinate axes is this y-intercept. Okay, well, to find that y-intercept, I could say g of 0, right? And g of 0 is going to be negative 2 to the first power minus 3, which is going to be negative 5. So I know this y-coordinate, negative 5, and I know I have the point 0, negative 5 on my graph. Okay. Now, for other points that might be easier for us to determine, let's say x was negative 1. If x was negative 1, I have negative 2 to the 0 power minus 3, which would be negative 1 minus 3, and that would be negative 4. So I know that at not negative 4, at x value of negative 1, the y value is negative 4. There I have that point. And without much other difficulty, I could say, well, what if x was 2? Well, g of 2 would be equal to negative 2 to the third power minus 3, which would be negative 8 minus 3, which would be negative 11. So I know that if x is equal to 2, the y value there is going to be negative 11. So I've got 3 points on my graph, the general shape of the graph. I have the domain, the transformations, the equation of the asymptote. So I need to make sure that I have these 3 coordinate points. And we said we had the point negative 1, negative 4, and we also had the point 2, comma, negative 11. How are the points selected? Just select easy points for the evaluation. That makes it easy to do. All right. So that's graphing an exponential function with transformations. Thank you very much for your time. If you have questions, please be sure to ask.